Good afternoon, grade 11s. So this is lesson number 5, and in the folder with lesson number 5 there are 2 videos. The one you only have to watch part of, and the other one you have to watch the whole one, but I will tell you when it is appropriate to watch the videos relative to this particular lesson, because this is quite a long lesson. It's meant to span 3 half-hour slots, and I don't want you to watch all the videos beforehand. You need to watch them when I tell you to watch them. So just quickly reminding you that last lesson we finished on how the eye functions to see an object. Remember that it's important that you know that light rays, white light, is in fact made up of rays of different wavelengths that altogether appear to be white, but in fact if you pass those light rays through a prism, then they become refracted and they will form a spectrum of color, and that's the rainbow of color rays that you know about. The red, orange, yellow, green, blue, indigo, and violet light colors. If white light falls on an object, depending on the material from which the object is made and the material covering that particular object, like here, the stop sign has been painted with red paint and white paint. Now, depending on the composition of that material, it will absorb certain of the light rays, some wavelengths, and it will reflect other ones. So if something appears red, it appears red because it's reflecting red light rays to your eye. That's quite a difficult concept to sort of take in, because it's like, what do you mean it's not red? What do you mean it's red? Because it reflects red. So what this thing has done is it's absorbed all the other colors of the spectrum and it's reflecting red. White, on the other hand, doesn't absorb any of the colors and it's reflecting all of them back to the eyeball, and that's why it appears white. Something that is black in color, in fact, absorbs all the light rays and doesn't reflect any, and that's why it appears to be black. So remember that what happens is those light rays that are reflected then pass through the eyeball. Some of them will, some of them won't. They're refracted by the cornea, because going from air to the cornea is passing from one medium to another medium. And you know that when light rays pass from one medium to another, they are refracted. They are also refracted by the lens, and that's important. Both the lens and the cornea are curved, and that increases their ability to refract. The greater the curvature of something, the greater its ability to refract. And then the light rays pass through the vitreous humor, where some refraction also occurs, and an inverted flipped image forms on the retina of the eyeball, and the rods and cones are stimulated and they send an impulse through neurons through the optic nerve to the occipital region of the brain, which interprets this as an image. Okay, right, so that is all about vision. Please watch the first minute and 50 seconds of the YouTube video, which is in the folder for lesson 5. Don't watch any more. We'll watch the rest of it later on, because the rest of it doesn't make sense. So, when a person looks from a distant object to a close by object, in order to achieve a focused image on the retina, the eye has to change. And this process is called accommodation. Now, under normal circumstances, when the eye is at rest, it is focused for looking at an object further than 6 meters from the eyeball. So what I want you to do is look out your window at an object which is more than 6 meters away. Hold your head upright so that you can see clearly through the window, and cover your eyes with your hands. Close your eyes. Don't look down. Just close your eyes. Keep looking at the same level. And spread your fingers so that you can then open your eyes. But when you open your eyes, you've got to be looking as if you were looking out the window. I hope this makes sense to you. Okay, so you've looked out the window, you haven't moved your head, you've put your hands in front of your eyes, you have spread your fingers. Don't put your hands on your face. Put your hands about 10 centimeters away from your face. Okay, close the eyes, spread the fingers, open the eyes. Are you focused on the distant object, or are you focused on your fingers? At the instant that you open your eyes, are you focused on the distant object, or are you focused on the fingers? If you focus on the fingers, you didn't listen carefully to me. Okay, try it again. And what you will see is at rest, the eye is focused on an object which is further than 6 meters from the eye. And at that stage, the lens of the eye is not very biconvex. So it has a very slight curvature. The lens is not very biconvex. If the object is closer than 6 meters from the eye, the biconvexity of the lens must be increased to increase refraction, to focus the light rays on the retina. And that process is known as accommodation. That changing of convexity of the lens as one looks at an object closer and closer and closer than 6 meters. Okay. Please note how to spell accommodation, double C, double M. Okay. So as the object moves closer than 6 meters to the eye, this is the process that happens. The circular muscles of the ciliary body contract and the radial relax, because you know that they're antagonistic to each other. The ciliary body moves inwards and forwards. The gap between the ciliary body and the lens is reduced, and the suspensory ligaments slacken. Now that's the word you've got to use. You'll see that the one video I've put on into a folder for you, talks about the suspensory ligaments relaxing. They're not relaxed. Suspensory ligaments are non-elastic. So they've got two positions. They can either be taut, T-A-U-T, like a piece of string if you pull on either end, or they can be slack if you don't pull on either end and you bring your fingers closer together. Then the suspensory ligament becomes slacker. This reduces the tension on the periphery of the lens. The lens becomes more biconvex, the light rays are refracted more, and a focused image falls on the retina. Okay, so that's accommodation. I would learn it as 7 steps. It's easier if you learn it as steps. So the circular ciliary muscles of the ciliary body contract, radial relax. Ciliary body moves inwards and forwards. The gap between the ciliary body and the lens is reduced. The suspensory ligaments slacken. It reduces the tension on the periphery of the lens, which, because it is elastic, becomes more biconvex. And because it's more biconvex, it refracts the light rays more, and a focused image falls on the retina. Okay, so looking at the right picture. picture here. Okay, this is all looking at objects closer than 6 meters. Because the circular ciliary muscles have contracted, the ciliary body has moved. When I say inwards, see it as a circle. So it moves inwards, and in fact, it also moves forwards. The suspensory ligaments slacken. There's less tension on the periphery of the lens. The lens becomes more biconvex, compare it to the one on the left, and there's greater refraction of the light rays. Okay, and that forms a focused image on the retina. And then the opposite happens when looking from an object that is closer than 6 meters to an object that is further than 6 meters away. So if you were looking at your book and then you looked outside to look at the white eye that is busy eating aphids on the bottle brush outside the window, and that's further than 6 meters, then the opposite thing would happen. The circular ciliary muscles relax and the radials contract. The ciliary body moves outwards. Look, it's moved outwards compared to the picture on the right-hand side. And it in fact moves backwards. That puts tension on the suspensory ligaments, which become taut. Please look how to spell taut. And that exerts tension on the periphery of the lens. So it's pulling the lens from all sides. The lens becomes less biconvex and refracts light rays less. If the object is further than 6 meters, there's no change. That's as best the eye can do. Okay. So these are two quite nice pictures. The only thing is, for some unknown reason, the optic nerve comes out there, and you know that it doesn't. You know that it comes out there. Okay. All right, so this shows you really nicely. And then these two pictures show the ciliary body. So 5 is the lens, 4 are the suspensory ligaments, and 3 is the ciliary body. And please be so careful, because do you realize this is incredibly easy to mix up with the drawing of the iris and the pupil, because the iris and the pupil work in a very similar way. So I used to be part of the matric syllabus, and I can remember a matric exam one year where they actually asked about the lens, and there was a drawing similar to this, and many of the students, I would say more than 50% of them, didn't read the preamble of the question carefully. And so instead of interpreting it as the lens, the suspensory ligaments, and the ciliary body, they interpreted it as the pupil, and the iris. And they answered that entire question incorrectly, and they got naught for that whole question. So be very careful. Are they asking you about accommodation, or they're asking you about the pupillary reflex? And are they talking about the lens, suspensory ligaments, and ciliary body? Or they're talking about the pupil and the iris, which looks very similar here. Okay. So remember that for distant objects, this is for distant. Okay. The light rays do not diverge widely. In other words, even if you look at a double-story house at a far distance, it's not very big. So the light rays from it don't diverge a lot. And therefore, they don't have to be refracted a lot. And therefore, the lens must be less biconvex. So the lens is less biconvex because the radial ciliary muscles are contracted and the circular ciliary muscles are relaxed. Ciliary body is out and backwards. Suspensory ligaments are taut, T-A-U-T, and therefore there's very little refraction and a focused image falls on the retina. Remember that this little part here is the fovea centralis. Then for nearby objects, so if you looked at that same double-story house at a nearby distance, the light rays which come off of it are far apart from each other. It looks really big. They have to be refracted more. The lens needs to be more biconvex. Remember, the cornea doesn't change. So while the cornea refracts light rays, there's no difference in the degree of refraction whether an individual is looking at a distant object or a close by object. It's only the lens that is able to increase refraction or decrease refraction. So for nearby objects, circular ciliary muscles contract, radial ciliary muscles relax, ciliary body moves in and forwards, suspensory ligaments become slack, less tension on the periphery of the lens, therefore the lens becomes more biconvex. So if you're looking at it from the front, I'm going to go over to the right side, looking at it from the front, the ciliary body has moved in, the suspensory ligaments are slack, the lens has less tension on its periphery, it becomes more biconvex, light rays are refracted more, focused image on the retina. Okay, and that's for objects that are closer than 6 meters. The eye doesn't change if looking at objects further than 6 meters. If you look at an object at 6 meters and 10 meters and 20 meters, no change. Okay, make sure that you understand those stages. So this would be if the object moves further than 6 meters from the eye, circular muscles of the ciliary body relax, radial contract. Ciliary body moves out and back, gap between the ciliary body and the lens is increased, suspensory ligaments become taut, tension on the periphery of the lens is increased, the lens becomes less biconvex, light rays are refracted less, focused image falls on the retina. I just need to warn you that many websites, many videos only talk as if there's one set of muscles in the ciliary body. They talk about the ciliary muscles. And there they are only talking about the circular ones. There are, in fact, 2 sets. They work antagonistically to each other. You need to know that the circular contract. So what you can remember is circular ciliary muscles contract for close. So C, 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 C. Okay. If the source is only talking about one set of muscles, then know that they're talking about the circular. Okay. So there is 2 videos there. There's also one in the folder for lesson 5. Both this one and the one in the folder for lesson 5 on accommodation don't use the term taut and slack. And those are the words you have to know. Taut when it's tight, slack when it is loose. Okay. I've told you it's terribly important that you mustn't confuse accommodation and the pupil reflex. So in accommodation, it is the lens that changes shape. In the pupil reflex, it is the pupil that changes size. Accommodation occurs for sharp focusing on near and distant objects, whereas a pupillary reflex occurs for controlling the amount of light entering the eye when light conditions change. In accommodation, it is the circular and radial ciliary muscles and suspensory ligaments. In the pupillary reflex, it's the circular and radial muscles of the iris. Okay. Please remember, and I've told you this I don't know how many times, about the fact that last year in the matric exam, in paper 2, there was a question with a table of comparison, and that the students did it really, really badly. And quite often when students do badly in something, for the next few years, the examiners like to ask that kind of question again and again. So it's terribly important that you're good at doing tables of comparison. There are always marks allocated for the heading. The heading needs to be complete for the information that is in the table. Then you need to have very clearly your column headings and possibly row headings. So a row heading here might be part that changes, part which changes. And here it's the lens that changes, and there it's the pupil that changes. Here you could even make this into 2 different points: the aspect that changes, the shape of the lens versus the size of the pupil. Remember that it's important that you compare the same things in the row. You can't say lens changes shape, whereas suspensory ligaments become taut or something like that, which is wrong for this one. But what I'm trying to say is you can't have on the same row things that are not comparable. Okay, complete activity 6.15 on page 193 of the textbook. Now remember, that's the grade 12 textbook and you don't have it, so I did put that onto Google Classroom for you. All right, and then we'll start with eye defects in lesson 6.